cognizant. Okay, I'll repeat myself. Thanks. So good evening and good morning, folks. Myself, Rahim Sheikh. I'm part of Cognizant Professional Service team, private cloud team. And I started with this team almost 1.5 years back. So today's topic is disaster recovery private cloud. We already have a session on the same topic, and we covered half of the points of this topic in the previous session. And we will be completing remaining tasks today, and we'll have some time for question and answers. But we will quickly run through the slides which we already covered, and that will give us some plans because I've noticed a couple of folks, they have not joined previous session, and they will just have some questions. But even if we miss to cover something, if we don't go in that much detail, feel free to reach out to me or anybody from my team, and they will definitely happy to help you. So topic is disaster recovery and private cloud. It's overview because with this limited time of session, we can't go in depth, but we'll try to cover topics as much as possible. And we'll quickly proceed with the previous slides first. So I had divided this session in 3 parts. First part was introduction and need for disaster recovery, where we talked about RTO, RPO, and some concepts, and there's some DR architecture. And second part was there with related to the DR products and solutions. And today we will be covering the implementation and DR for XYZ or any mock company, where we can start with DR site selection, DR strategies, implementation, how we will do the discovery and assessment, what are the documentations, and how to create the design diagrams. And we will also talk about the DR networking and the recovery for infrastructure and the application. We will talk a little bit on the doing proof of concept for disaster recovery and the DR test, and we'll just give we'll just do some discussion on DR test versus real disaster recovery and the difference in strategies for both the things. We'll talk a little bit with a DR life cycle, and we'll give some time for question and answers after that. So without further delay, let's proceed and at least cover these two chapters which we already covered, and we'll just quickly run through that. We will not spend in depth. We'll just quickly run through the slides, and we'll just give some high level information on that. Let's get started. So what is disaster recovery? We talked about the disaster recovery set of best practices and process documentation and tools which helps to do the IT infrastructure and application recovery in case of natural or man-made disasters. And disaster recovery is part of the how disaster recovery is part of the business continuity. We already talked about this, and my colleague Partha spoke about that. We will be focusing only in the disaster recovery practice part here. The way of the disaster or the types of disasters could be happen because of the flood, earthquake, power outage, virus attack, ransomware, human error, or there could be many other factors which can be considered as a disaster in the infrastructure, and we can think about doing a recovery and keep the business running. There are some concepts which we already talked about: the RTO, RPO, DR scope, failover, and the failback versus full versus partial recovery. So I'll quickly run through RTO and RPO because this is very important. So RTO is the time basically we take to do the we start recovery and finish the recovery. And if as a service provider, if you work for an organization, and when you calculate the RTO, there is a penalty if you don't do the recovery in time. You might need to do some credit to the customer. So RTO is kind of a time to make sure that customers or the infrastructure and applications are recovered within that particular time. RPO is recovery point of object, which basically talks about how old your data is, and it means if you're replicating your data with synchronous replication, your RPO can be in minutes. And if your disaster strategy is based on backup and restore, it can be on hours or days, how frequently you do the backup and ship that backup data, or you replicate that data to the DR side. DR scope is the detail for your servers and the applications for which you need to do the disaster recovery. Uh, Failover and failback, it's a concept where failover where you actually start doing recovery and which is being measured under the RTO. And failback is the process. Once your production side is up, you replicate the changes happen to the DR side, you replicate back to the production and do the recovery. That process can be called as a failback. Full versus partial recovery is kind of a concept, like whether you wanted to do the recovery for entire infrastructure or just part of the infrastructure as a couple of applications. Quickly go to the next slide. We talked about the traditional versus automated DR, and how it was difficult, or how it was different in the current scenario, where we use the automated tools for doing automated recovery, and traditional way was to do just with the help of backup and restore our tapes, or building a physical service from scratch. With the automated DR, we talked that day we can use storage-based replication, we can use agent-based replication, we can use database replication, or SRM to do the automated recovery, or whisper replication with the help of in conjunction of SRM. And we can also use the latest backup and replication tool like Vim or Ember, which takes the backup of virtual machines and do the restore with transport that data over the WAN and can help to do the recovery. And there is new concepts also coming into the market as we are evolving and using a public cloud more often, and the new features and services are being offered by the public cloud, like AWS and Amazon. They're offering recover to cloud feature. Also, there are some vendors, they provide recover to private cloud, so that features can be also used. And when I was working in my previous experience or my past company, I was working as a recovery solution architect for disaster recovery, and we were selling our service on disaster recovery on private cloud as well as public cloud with the help of automation and some tools. Uh, there is concept called one button DR. It's like you just hit on that button, and your infrastructure or your applications are protected to the DR site, and it's always ready to do the recovery in case if you have a disaster of your production site. This is a oversimplified DR architecture document we talked and just to give the understanding about how disaster recovery and help you to understand some concepts here. So if you look at this, so at your left side, you see your branch office, your production data center, and some remote users are there. And you also have your cloud connectivity with your production data center. And you're continuously replicating your production data center to the DR sites. In case, as you're replicating your data, so your servers to DR site with this dark green link, just assume it's a replication via storage or SRM or any DR product which you're aware about. If your production site goes down, your servers and applications are down, and your connectivity for replications also down. When this site goes down with any man-made or natural disaster, your branch office lose the connectivity to it, and that application is not available to your branch office. Also, you don't have connectivity with your cloud or public cloud, whether it's AWS or Google or Azure. Your users which were using your production applications also not using, or they can't use it because your site is down. That time you can your team can work on getting connectivity established with your cloud and the branch office, and same time DR team can also do the recovery. And once your sites are servers and applications are recovered at DR site, your remote users and branch users can access your servers from the DR site. And this process for making the connectivity with your branch office and cloud, as well as doing the recovery for servers, can be considered as a failover, or doing the disaster recovery test or actual disaster recovery. And once this is done, your servers are running, then your users will be able to access your. So access your applications and servers from the DR side, and the amount of time you spend to do this recovery can call as a RTO, recovery time of objective. And the data, for example, you were continuously replicating your data to the DR side, and you have 30 minutes old data. That means your RPO was 30 minutes. That means your data which is recovered at DR site is 30 minutes old, or your RPO is 30 minutes. Some DR products which we talked in previous session was VMware SRM and how it works with vSphere replication and the storage replication. And also difference with in the storage replication, there are two types of replication, synchronous replication and asynchronous replication. We also talk a little bit on Zerto. If not, I will quickly run through the Zerto slides and what are the components comes with the Zerto. It's also a very famous tool for doing disaster recovery. And I've also seen that some of the customers use Zerto for the migrating their workload from on-premise to cloud. What are the agent-based applications? And uh, uh, we talked about Azure site recovery. Previously, it used to call as the InMarge. It's also and the cloud Endure. They are agent-based application, which means there is some kind of agent or application running on your Linux or Windows machine, which keep tracks of your change block tracking and send that data to DR side, and the DR at DR side the master target servers or the whatever components are running for that particular application vendor, it's keep tracking that data and updating that to the DR site virtual disk or the virtual machine, and helps you to use that data to do disaster recovery. We can talk about a little bit on backup and replications, like the tools. And after that, we talked about the recovery strategies and procedure documents last time, like how the recovery strategies and what are the recovery procedure documents which can be used for virtual machines recovery, and how it's difficult to do the physical servers recovery, and what are the steps needed to physical servers doing the fresh build or a backup and restore on physical servers. How the Windows servers and Linux operating systems are different, and the recovery strategies and recovery procedure documents can be different for the Linux operating systems. Database recovery, we talked about how we can use inbuilt feature comes with the database servers, like you can replicate your database with the mirroring or a log shipping. You can also use some new technology coming with the public cloud, where you can replicate your database to the public cloud and keep that public cloud database as a secondary option for your database recovery. And using this all three virtual machine physical servers or database, how you can think about application recovery and what documents will be required for application recovery, and how you can strategize and and do the planning for application recovery, how the startup process and how these things will be there. So we will be talking separately on the application recovery in future, in today's slides in detail, where we will be doing the actual DR implementation for a mock company. There is definitely a separate recovery procedures and recovery strategies for Unix boxes, because I've seen a couple of Unix boxes, like few customers, they still use old Unix servers or Solaris or Linux or i-series servers, which required a separate or dedicated replications or a dedicated recovery strategy. Automated and scripting in DR, how we can use it, and how. So basically, why do we need automation and scripting in DR? So in the disaster recovery, we always talk about the RTO and RPO, and whenever you have a call or a leadership, they always have a one goal in their mind, that how their infrastructure is well defined in architecture, and how they can decrease the RTO to decrease the number of hours or changing it to the minutes, and also the RPO, improving RPO, so that their data is in replicated data is in some minutes or some milliseconds, so that they don't lose the actual information in the event of disaster. So we can use some PowerShell scripts or PowerCLI scripts, the network changes which are required. So we can run some kind of script for changing a DNS or making the host find changes or changing the Linux mount points and all those things. This application installation, failover, and failback, all those things can be utilized while doing the failover and failback process. We talked about VMware Site Recovery Manager, and we had an in-depth discussion on that, how it supports the vSphere replication as well as how it supports the storage with replication. And we talked on NetApp storage and how the SnapMirror help to replicate the storage and all the files which are related, which are there in your production vSphere environment. And once it's replicate, how we can use SRM and DR vCenter to how to create the production plan and recovery production groups and recovery plan, and automate those recovery in the event of to use in the event of disaster, or do the DR test and follow the best practices. I know we are going a little bit faster, but we have the today's slides, which will be where we will spend most of the time, and we'll have enough time for that. And if you have any questions, feel free to stop me in between or post in the chat, and I will try to answer my best. Oh, sorry, there are some questions. So there was a question on what is the backup and replication tool we refer here. So we are talking in general, all the tools. So we are not talking any specific, but there can be some topics which we can cover in future where we can speak specifically for a Vim backup or Avamar backup, which I'm aware about. There is one more backup tool which I have experience called Actifio, which is kind of a snapshot backup, and it's really helped to decrease the RTO and RPO to 30 minutes, where other backup kind of having a daily backup or a twice a day backup, which kind of a difference. But unfortunately, in this session, we're talking about it's overview session or overview training, and within 1.5 hours, we won't be able to complete a specific backup tool. But we can have the separate backup session if required.
Okay, thanks, Rahim.
Yeah. So going to the next slide. This is again another slide where we talked about the components in SRM and how the SRDF replication basically works. So while doing the SRM implementation, we already talked on this. What are the steps are required to do the actual SRM implementation for, and it's kind of a greenfield implementation when you do for SRM implement, do the SRM implement, SRM install and configure and manage for any company, provided you are using. I talked about I mentioned SRA adapter here. So I'm kind of having huge experience on just using the storage-based replication, because I was working with the company called SunGuard, and all the customers they were just using. So infrastructure was designed to use the storage-based replication with NetApp and EMC. So unfortunately, I don't have in-depth slides on vSphere replication, but we can talk a little bit about it if required. So whenever we do the SRM implementation, just assuming that your production side is ready. So with your production vSphere infrastructure where your ESXi and vCenter server is running. So we just need to do the DR side implementation here. So we do the vCenter server and the SRM server installation at DR side, and we do the configure networking. Yeah, I mentioned configure networking very high level because we need, when we select the DR site, there has to be a site-to-site VPN or MPLS connectivity, because you cannot have your same site running for your disaster recovery, because just assume you have a production site in New York, and if you select the same like few kilometers from New York, and if you have any tsunami or any kind of natural disaster there, like earthquake, your production and DR, both sides will go down. So when you do the DR site selection, and we will be talking in that in detail, like how to do the DR site selection, or what are the best practices to use the DR site selection. So, and when you have the two sites or these sites, multi-sites uh, in two different geographical location, you need to have the site connectivity with the MPLS or site-to-site VPN. Once this connectivity is there, the first thing we do the site pairing. We install the SRM server at production site, and we pair those sites with each other so they can share the information with each other. And for SRM with the storage-based replication, the requirement is the storage should do the replication or data replication, and SRM will just do the automation for recovery and doing the protection and keeping eye on the replication. And we have the SRA adapter component, which kind of installer or the appliance which runs on your production as well as DR side, which keeps talking to your storage, and they share the information with each other, and they make sure that replication is good and there is no problem in the replication. In case if there is a site connectivity issue or a huge data pending to replicate, that's also throw another that alarm, so that your replication is at risk, or your RPO is increasing and you are not compatible to do the recovery within the RTO time or defined time, or you might lose data when you do the DR. So this task related to SRA adapter, and it's have that communication between, it's kind of a mediator between the SRM server and the storage array. When you do once the data is replicated to the DR site and they are in continuous sync, we create the protection groups, and it's keep eye on the health status for the protection group. Once the protection groups are ready, we create the recovery plan, and we configure the recovery order for the virtual machines as per the recovery order. And we define that first which virtual machine needs to be start, and if the database VM needs to be start, and application VM needs to start off that, and there has to be a 20 seconds delay in between. So we can define that delay. Also, post restart or post start script, we can also define those things in the recovery plan. And then we perform the DR test, and we do the validation for servers recovery and the application recovery. In the DR test, and thing is, we can do the DR test in isolated environment. And when we do the isolated environment, your production server are running. Like I'll quickly go back to your site, old slide here. So just assume we are running the DR test here. My production is running, and I'm going to bring all these three same servers to the DR side. And if the sites are connected, like a domain controller can see that, okay, I have same name domain controller, and there could be issue with the replication. So we with the help of SRM, we can do this recovery in isolated network and isolated environment, where it can create the new port groups, and we can use those port groups to do the recovery. And these servers will talk to each other, and there won't be any packet will be sent to the production and will not create any problems. So test can be done, and also once the test is done, we can destroy these VMs, and still the replication will be as is, or we can pause the replication while doing the disaster recovery test. I will go back to my slide. When the DR test is there, we can just do the recovery validation, and we think about failover and reprotect. If we need to do the DR test with failback as well, we can do that, and we can do the reprotection, and we can do the failback in case if there is a disaster, actual disaster. So I'll just quickly talk about actual disaster here. So if you think that, just assume your production site goes down and your VMs are running from here, your DR site, and your users are using it, your business is running, and just assume last 7 days you were running everything from your DR site. So whatever changes was happened at DR site got stored in this DR data store and DR storage, which gets replicated back to your production. And once it is replicated and everything is replicated, you can shut down these VMs and power on the replicated VMs with the changes at production side, and this process can be called as a failback process and bringing back everything to your production. So this is kind of SRM implementation. We like high level steps which we perform. Zerto, it's another appliance or another product which is also a very good tool for using disaster recovery. So just assume this is also a very high level architecture document which talks about Zerto. So SRM required storage to replicate, storage to do the replication or use the Whisper replication. Zerto is kind of, they come up with the ZVM and its appliance, which runs on the each host, which keeps eye on the whatever changes is happening on the virtual machine. And it sends all those data, like this is, I'll start from over. This is my product side, or this is my production side, and this is my DR side. While implementing Zerto, you need to make sure your both the sites are up and you have your production site ready, uh, production site ready with ZVM, and DR site having ready with the ZVM, and you have this site pairing again needs to be done with ZVM. They talks to each other and share the information. Then ZVM helps to install this VRA. It's kind of an appliance which keeps track on each and every virtual machine disk changes. So whatever changes is happening, all those changes will be sent from this VRA to the target or destination VRA at DR site. And this VRA, destination VRA, create new VMDK or virtual machine and write all those changes to the virtual machine shell, which is created at DR side. And once all the data is replicated, these VMs are ready to do the recovery. When we do the first time implementation, entire data is kind of replicated from production to the DR side. And then once everything is replicated to the DR side, then only delta changes, which will happen at the production side, will get replicated to the DR side. Still, I've seen sometimes, I'll talk about that issue in later slides. So I'll just keep it simple for you. And this VRA will be on every host at production site. We'll have one VRA because it needs to keep track for all the data changes which is happening on the storage behind the virtual machine, and it sends that data to DR side. And once you do the DR test, ZVM simply just use this VMDK. So we have two options: either use this snapshot VMDK out of it, or use the original VMs and power them on and do the DR test or actual disaster. And Zerto gives the RPO of 30 minutes. And if we have applications with the less data change and data is not changing drastically, I've seen some servers where having the RPO of less than 1 minute, and whatever data was getting replicated to the DR side was in few seconds. Like, so when we do the DR test or recovery for servers, it was having the latest and greatest data available, which was few seconds or few minutes old, replicated from production to the DR side. The beauty about Zerto, it has the agent as well. So Zerto also helps to replicate the physical servers from production to the DR side. But only question here is sometimes we might see the blue dump after doing recovery, so we have to do additional troubleshooting from the Microsoft side to fix the drivers or the drivers related or the firmware related issues to the DR side, because P2V it's not always running, and we might need to do the P2V conversion after doing recovery. The bad part about Zerto doesn't support the RDMs. So if you have virtual machines attached with the raw device mapping, that data is not getting sent to the DR side, and you won't have the virtual machine protected. So if you have the raw device mapping at the production, you might need to think about having the different recovery strategy or different tool for those particular servers or virtual machines. Azure Site Recovery, that's another product. Previously it used to call InMerge. It was a Bangalore-based product company. They developed the product based on CentOS and the VMware. They also use the VMware converter to convert virtual machines. And the beauty of this product, it can replicate the physical as well as virtual machine to the rear side. And this is an agent-based replication. So it uses the agent. So we have to install agent on every virtual machine. And at production, there, as per the virtual machine load, we have to deploy the process server. And every agent send that data to the process server. And process server have their depending upon the data size, you need to attach the number of disks to the process server. And at DR side, you need to have the master target server. So master target server keep pulling the data from process servers and writing into the VMDKs. And master target server is always a virtual machine, and it has the number of VMDK attached to it, and it's all automated, so you don't have to do. You just configure the master target server and protect the physical server and virtual machine. It creates once you protect the disk, it automatically creates the number of disks attached to it, and it starts replicating that data from prod to the destination. And once the data is replicated, so it's replicate data again in two phases. First is replicated that I'm sorry, I forgot that phrase, but it's replicate entire data from scratch from production to the DR side, from scratch to the end. And once all the data has been transmitted, the disk or the server just came into the bitmap mode, and that bitmap mode, once the server is in bitmap mode, it just translates the data or it sends the data to the sends only data change tracks or delta change tracks to the from production to the DR side. And it also VMware it uses VSS shadow copy. So when it's capture that changes, it's use the VSS to do the snapshot of the file system and take that data, put the servers in the bitmap mode, and send the data to the target. Once it's written into the master target server, basically it's sent to the process server, and process server, master target pull the data from process server and write into the VMDK. And when we do the DR test, it basically just detach the VMDKs and assign the VMDK to the virtual machine shell, which gets created when you protect the virtual machine and power on the virtual machine. And recently it was, not recently, but a few years back, it was acquired by Microsoft, and then they changed the name to the Azure Site Recovery, and now they have option whether you wanted to replicate the data to on-premise based on a vSphere or the Azure cloud or VMware cloud, wherever you want. You just deploy this process server, master target server, and the config server, which basically just keep the operations or kind of a management server called as a CS server, which do the tracking for protection and the recovery. Any questions on this topic? Because after this, we will be going to today's topic, where we will be spending most of the time, where we will be implementing the DR for XYZ company or any more company.
Yeah, Rahim, any specific security algorithms, we get, through this Azure Site Recovery Manager, if at all they want to replicate, encrypt data in motion. So any security features are there, or it's all open data, anybody can tap it?
I think there is an option like ASR comes with two things. I remember encryption and compression. So if we enable that, that can be done. But most of the time, I've seen that disabled if you have huge kind of a database servers with huge data change rate. So they try to disable that because it use the encryption keys and PKI, I guess. With the help of that, you can encrypt the data or the transmit. ASR can do that.
Thanks, Rahim.
Yeah. Even Zerto can also do that. It's like it's encrypt and compress the data, but based on the requirement, we can make the changes in the strategy.
Good.
Rahim,
And
Tejas this side. Rahim, I have a question regarding the Zerto application basically. If there is a network latency or if there is any issue with regards to the network, because network is a key component here, right, which is transmitting
yes,
the data. So what if
yes.
we are in a phase of doing replicating data and my recovery side goes down or it goes out of sync? So what is the mechanism, or do we have to follow some tedious mechanism to, or it can start with the same point where the replication has stopped?
It stopped. It stopped where the replication was stopped because it's based on what step you are on. So if you are replicating that first time replication, and if it's broken, you might need to re-replicate everything. But if it's kind of replicated everything and you are just in like bitmap replication or a synchronization where whatever changes, only the delta will be changed. That time it will pause and it will resume, because this Zerto, ZVM, and this VRA keep eye on what is being sent from VRA to the destination VRA, and it checks that if it doesn't get the acknowledgement, it's again send that packet from production to the DR side.
Okay.
And just if you have the limitation on limitation on the bandwidth, like you're using site-to-site VPN and the bandwidth is not enough. That time we came up with like we can skip some drives, or we can um, skip the drives which are not needed. Like I've seen a couple of users or companies, they were having database VMs replicating from production over DR, and they were taking daily local extract copy on some drive like Z drive. They're having daily backup, and that Z drive was also getting replicated. And every morning, 4 a.m. or 1 a.m., the virtual machine status or application status used to go in red and was showing out of sync, because immediately it was some terabyte data was dumped and it cannot be replicated within time. Then we had a discussion with customer. We identified what kind of data is being generated, and then we skipped those drives, and we tried to resolve the issues that, because it was not needed, because it was itself a backup getting replicated,
Makes
so we
sense.
don't need backup. So we skipped those drives and we try to achieve the RPO in time.
Thank you, Rahim. That
Yeah,
helps.
we also suggest like multiple times it's happened. We skipped from site to site VPN to MPLS, and I've also seen that sometimes the bandwidth was not huge, fully utilized. So we also decrease the bandwidth as well. So depending upon the, so it's completely factor on your production data change rate, and then you need to think about making the changes or improving or decreasing of your bandwidth.
Thank you, Rahim. Thank you.
Thank you. Okay, so let's get started with this implementation for a company. Any company we can think about, and what are the high-level stages we need to do. Of course, there will be many changes in between when we do the implementation, but still we'll try to cover. Just assume we need to do the implementation for XYZ company, and what are the steps we will follow. So we start with the DR scope discovery whenever we do any kind of implementation, whether it's a greenfield or brownfield or any upgrade. Then we'll, as per that DR scope and discovery, we think about the strategy, that what best strategy and what tool will be helpful for this company. And then once the strategy is defined, and then we can think about the network and replication. Of course, we will be talking about Zerto or the SRM here, because we can also talk about backup and restore. But that time, we can think about shipping the disk or shipping the backup tape to the DR site. Then we can once the network and replication is done, we'll talk about the recovery priority, because why we need to recover, because we cannot recover everything in one go, right? We have to recover step by step, and we also need to bring the application as per the recovery strategy, because always every company will have their own application and tools team, which basically the infrastructure team will not be able to do the application recovery, right? So application team will come and they'll request, okay, we need to have this prioritized, and we can automate these things just to improve the RTO. Then we can perform the test or a proof of concept, or we can just do the POC for a particular application and making sure that, okay, that is working. And then we can think about, okay, everything is protected, and we can start from small picture, and then we can go to the big picture. And at last, we'll talk about DR lifecycle, because everyone stop here. Okay. And once DR test is successful, everything is implemented. Okay, they are done, right? But after that, they forget to do the DR life cycle. Then after that, they change everything at production. They add new servers, delete some servers. They never update their DR config documents, or the we can call it as a run book or playbook or any documentation. They don't update their DR diagram. They increase the capacity of replication, or they decrease the capacity. Sometimes they add new servers. They never protect them. And then when they do the DR test or actual disaster happen, they identify, oh, these servers were never protected, and their DR life cycle were never part of any discussion, right? So this is important factor which we practiced a lot in our with our customers, and I just wanted to share that with you. After that, we'll have some question and answers, but feel free to ask or stop me in between. So discovery, scope, and DR site selection. I just combined this part. So whenever, if any company or any customer comes to you, and you are as a service provider or as a consultant, you work with any customers, and you get tasked to do the DR implementation. First, you go and you do the discovery and assessment, because you go. So this can be automated, this can be manual. You need to go and talk to the customer and do the understand their application, their infrastructure, right? How it's implemented, like the authentication, the way of authentication, what kind of DNS they are using. They are using on-premise DNS servers or Infobox, or do they have any cloud dependency for their application? What kind of licensing? Like you might see some servers are having the licensing configured with some kind of USB key, and that key needs to be available at DR side. Without that key, your DR will not work. So everything can be documented, or everything has to be documented in your DR documents, and that can be found and done in your discovery and assessment part. For doing the understanding, we used to have the multiple sessions with the productions engineers and architects, and our one guy, one architect, or one engineer, or one DR guy will not understand every infrastructure, like Windows guy. So we used to have our lead architect, and he used to work with his internal team, like a backup architect, Windows architect, VMware architect, Unix, Linux architect, and we used to have multiple sessions with the customer's architect and the team, technical team, and understand their production, how it is configured. And we used to document each and every point was provided by the customer. We used to review their infrastructure. We used to identify the infrastructure, what is connected, what. We use some automated tool, like you might have heard about HP ADDM, or for VMware, you might have heard about RV tool, because pretty every administrator and architect talks about RV tool, right? And any data you need to pull, you go and you read it from RV tool, correct? So we used to get those data, and we used to perform the analysis. Then defining the scope, right? You cannot replicate or backup and restore your production, your test and dev data. Do you need your test and dev data at DR? No, you don't need that. You need your business to function, and you need to make sure your production servers comes online as soon as possible without thinking your production or your development data. So that's why you need to map the scope, or you need to lock the scope, so that once you lock that scope, then you cannot so your customer don't go and amend that scope, or if they need to protect new servers, they need to make sure they add that into scope. So you can think from billing as well as billing standpoint, as well as recovery strategy standpoint. Okay. The important thing here, server and application mapping. Most of the companies we support, and you might have seen, they don't have proper server and application mapping. Like they just think, okay, they just talk, okay, they need to do the recovery for Max server, or they need to do the recovery for any infrastructure application, and they don't know how many servers running these things. So you need to sit with them and you need to go through their inventory, or some kind of automated tool which basically go and check XYZ or any particular server is communicating with which servers. Like for authentication, it's use Active Directory. For DNS, it's use Inflobox. For database, it have some database server. For application connectivity, it has some application server. For web servers, it has connectivity with some web servers. You need to think from public DNS standpoint. Everything you need to document, and you need to make the mapping for that. And you can have a separate documentation for application mapping purpose. Then in we talked about the disaster recovery scope, right? Once the scope, so when you do the scope, you need to log that scope. So beyond that scope, you are not liable to do the recovery. So in case if you forgot, or if customer doesn't provide any information for XYZ infrastructure or application, and if they ask you, so you can specifically mention, or you can specify that, okay, this particular server was not part of scope, so we can't do the recovery. Or if it's not part of scope, it is not part of backup or a replication, so we can't do the recovery. Test and dev servers, we talked about it, right? So if customer says, we have some test servers and we don't use it, but sometimes there is a reverse case. They think, okay, it's a test and dev server, they don't use it, but sometimes they have the production data onto it. So with the help of discovery and assessment data and ADDM or any kind of tool, you can identify and checking. You can check that why the dev servers is continuously sending and receiving data from your production servers, and you can have that checked and skipped from your scope. Recovery order and priorities, that needs to be discussed with the customers, because or the application team, because they know how to bring up your application. Just as here, you have your production site, and everything is protected, okay, and all your users or application and tools users, they were located, and there is huge impact on electricity or the internet, where they cannot log in and do the recovery. So they cannot, if they are not there, they can't do the recovery, and you can't wait for them to come back online and do the recovery. So you need to have everything documented, and you also need to have everything understood from them. So even if a production team or an application team is not available, the DR team or DR documentations are enough to do the application recovery, or everything, any steps or any information which is there is documented. Important point, I left it at last, because the DR site location and DR site selection is very important. You need to make sure from geographically wise as well as infrastructure wise, you select your DR site location correct. Because if you don't select your DR site location, there could be a mistake, and then you might end up not having proper disaster recovery configured. So make sure you're not in same city or same location. You can think about different state or different territory. Like your production is in New York, you can think about having DR site in San Francisco or any other location, so that all your production is in California. You can think about having the recovery done in Pennsylvania or any other city or any other state. So even if some tsunami or power cut or internet cut or any other man-made disaster happen, still your data is safe at DR site location, and the DR site is not affected with any kind of cyclone or anything. At the same time, when your production site is also affected. Or you can think about having multiple DR sites, like one site is in APAC, another site is in Europe, another site is in North America. So then you can think about having the multi-site disaster recovery planning. Any question on this slide? Okay, I'll take it as no, and we'll go to the next slide, which talks about the DR documentation and DR kit. So we talked about the assessment and interviews and questions and session with the production team. But where do you need to document? You need to have a proper playbook or runbook configured, and you can have that configuration saved in some kind of documents, which is always available at DR site or DR architect or with the DR coordinator. Because in every organization, there will be a team, can be a dedicated called as a DR team or DR coordinator or any vendor who basically do the all DR stuff. Because just imagine if you have something down at your production, and if your production team is not available, you need to have somebody to do the DR. So to do the DR test or actual disaster recovery, right? So your production admin and DR admin cannot be the same. It's best practice to have a dedicated DR team and DR coordinator who thinks about this thing, this practice. So we used to call it as a DR config or DR configuration. We can call it runbook. We can call it anything. And it used to be mapped with the CMDB. And when I talked with the DR lifecycle, it's always updated. So we used to have a regular meetings with the production teams or admins. We were part of their change management team, our change management meeting, where we used to review the change management plans from the customer side and understand that, okay, they are going to make these changes and decommission XYZ server and implement new servers with this so and so operating systems and so kernel level. And we need to make sure that, okay, that operating system and kernel level is supporting the DR strategy and DR application which we are using for replication. We also need to make sure that the old server has been decommissioned and can be skipped from the replication or backup, and we need to reprotect or backup the new servers. We also need to identify, okay, any changes in the recovery strategy or any changes in the application. We also need to make sure, okay, so earlier we had all Windows 2012 or Windows 2016 server, but now the servers are Windows 2019, right? So we will have a dedicated DR kit where we will have all the installers and operating systems where 2019 installers and their software and license keys are available, so that we can make sure that in case of disaster, if we need to build the servers from scratch, that can be used. And if they are building the new servers or upgrading their software, so we need to make sure that the latest software which they install at production, that's also available at DR site, depending upon the DR strategy. Then once we have this DR config ready, we need to make sure we have high and low level diagram for disaster recovery or for production and DR site. Like, so when we do the DR, if you think about your production infrastructure, whatever diagrams were there for your application, those diagrams are matching at DR site. And just give me 1 minute. Sorry for that. I'm back. So so your high and low level diagrams are always updated. Just I said, if you upgrade your production and the bandwidth between production and DR site, you need to make sure and you go and update in your low level diagram. If you change any switch at production side, you go and you update your diagram. Because you need to make sure what IP, what configuration, what kind of licensing, everything you need, whatever changes is happening at production needs to be updated at DR site. Recovery procedure document and application recovery document. Every system needs to have a recovery procedure document. For example, just assume you have a some servers needs to be built and installed from scratch because they have some operating systems which cannot be replicated or some applications which doesn't support the replication. So that time you need to have a step-by-step document, and you need to make sure all the steps are captured, because the DR team who are going to do the recovery, they're not the same application team or same infrastructure team will have the existing knowledge in their mind, and they can just follow the steps they used to do as a daily practice in their production. So everything needs to be documented in recovery procedure document. Also, the application recovery document, if you have a contract with the customer or vendor where you ask them to do the recovery. So you need to provide what steps they need to follow to do the application recovery, like the authentication purpose, they need to configure or set the correct Active Directory server. For DNS, they need to configure the DNS setting, and the for database or application or web servers, they need to do the mapping. And for public-facing web servers, they need to update the DNS records for with the public IP, because you will not have the same IP at the DR site, at least for the public-facing IP addresses or the public IP addresses. Next part of the DR kit is DR kit. I used to call it, you can call as a DR kit, or you can call it as a separate DR installers or separate separate store where you keep all the installers or operating systems or backup data, license, all the information, whatever information, even the documentations for your configuration, CMDB, the recovery procedure document, everything can be implemented in that kit, and you can call it as a disaster recovery kit. So in case if you invoke the disaster recovery, you will go and you'll check. First thing you'll go and you'll check the DR kit, and you'll go and read the procedures and step-by-step diagrams, step-by-step guides, and the diagrams, and follow the process to do the recovery. Any questions on documentations and DR kit?
I have a question, this Shankaran. With respect to the DR, right? So nowadays, so this hybrid concept is coming up. For a couple of servers, we can maintain the DR servers on the cloud. Couple of them we can maintain at on-premise itself, right? So do you have any such case studies and the cost comparison when we host the DR servers on the cloud? Okay. So instead of hosting the servers in the on-premise, the DR server, is there any cost comparison or any case study?
I don't have any cost comparison, but we can definitely have some kind of a discussion, or we can create some kind of sheet where we can define some cost, because when we do the DR, like a company, if they have a dedicated DR location already defined, or if they have any vendor with them, they will have a different cost. And when we do and they have to do the investment in upfront for the hardware and software. But if they go and do the contract with any cloud provider, they have to make the regular payment for a replication. And if they look in the long run, they might think, okay, it's completely based on the requirement and the scope what they have at their production, and then we can think about having those. So we can basically create the Excel sheet and kind of a template where they fill in the information, and then we can define that what solution will be best, or how we can fit in the hybrid environment, that which systems will go on cloud and which system can be on premise, or how we can think about having the dedicated vendor for these kind of servers. Like physical servers can go on a vendor, and some virtual servers or the applications can replicate to the cloud. And at the time of DR test, we have the site-to-site VPN connectivity implemented with them, cloud and the on vendor, and then they can take the best out of it.
Absolutely, that's great actually. Yeah. So this the cost on the cloud, right, based on the data transmission, the replication of the data, what is the volume that replicate to the DR side? Yeah. So
absolutely. And also, if you look at the cloud, like you won't find the replication to the iSeries, right? So you can't replicate iSeries to the cloud. And then you'll have to replicate to your DR site or some kind of vendor who provide that service, like co-location. And from co-location, you can have some cloud connectivity, and then you can have this hybrid implementation.
Yeah, absolutely. So we cannot follow the uniform methods, right? Because based on the application, right? Because the compatibility, all those things. Yeah. Thank you, Ragan, for your answer.
Sure. Okay, let's continue. So next part is a hardware requirement, and that's where we can also talk in detail here. So like a physical service, right? So like AWS came up with the new thing. called the VMware Cloud on AWS. So if required, we can think about having the SRM implementation on AWS, but still that also add that's help you to not to do the upfront investment or capex investment to the DR side. Like you don't need to go and buy the hardware and the storage for doing replication. But if you look at that over the period of time, once you start replicating data, you'll start spending the amount a similar way you might have invested in your cloud. So depending upon the investment or depending upon the requirement, you can think about having the disaster recovery strategy. On a physical servers, for physical servers, what kind of hardware requirement I will require? Like iSeries, we talked about, we might need another iSeries box, or we can rent an iSeries box and we can replicate just the data to some kind of storage. And then at the time of DR test, we can rent or we can have a dedicated hardware. Depending upon the RTO and RPO requirement, we can select the strategy. Network devices, well, we also need we do the DR implementation, we will require network devices. So if you have a place called DR site dedicated, or you just rent a space in a co-location with any vendor, you still need to go and you need to have your physical servers, your network devices installed, and then set up the connectivity with your production and DR site. For your always on servers, you will have to do the investment, because every organization, they always think that, okay, the best practice is to have their Active Directory server always on, at least a read-only Active Directory servers always on available at the DR site. So in case of disaster, they can use it for authentication purpose, and they don't need to build and restore the Active Directory servers. Or if they need to, even if they restore the Active Directory servers, it can take the updates from that always on Active Directory server, or they can still do the authentication if they wanted to run some always on servers at production or the DR. There might be this could be a mistake. The scope validation should not be part of hardware requirement. I might have put it wrongly. It could be considered in previous slide, but we'll just need to make sure the scope is validated as per the hardware requirement, like whatever there in the scope. So if you have any VM which required a physical connectivity with some USB dongle, that can be also considered with the hardware requirement. So VM requirement and ESXi mapping. This can be a separate topic. Like if you have thousands of ESXi servers at production, and out of that, you just need 500 of them. So how many ESXi hosts you need to keep ready at DR site to make sure when you do the replication and recovery, you can use them with the help of SRM or any tool you use, but you can use them as a resources. So this thing can be also an important factor which we need to consider and make sure this hardware requirement is met at DR site. And Unix boxes matching with the recovery strategy. I only know for iSeries because I worked on that. So we used to have a tool somewhere or software called as a Maxava. We used to use for iSeries recovery, and data used to be replicated on some IBM V7000 or some servers from prod to DR, and they used to use some Maxava application to do the recovery of iSeries boxes and do the use the data from that servers. We'll go to the next chapter, and we'll talk the DR networking, how to set up the DR networking, and what are the important factors when we consider the DR networking. Any questions on the, or anybody wants to suggest anything on the DR networking part, or any experience on DR networking? I'm asking this question just to make it more interactive.
Yuvraj here. I did work for Zerto, but we do a ASR recovery on a different way. So what we do is we have a management service. We provide AD, DFS, or your antivirus solution, tool solution as a separate. So few of those solutions will be in active on 2 different regions, but like a file transfer where requires a huge license cost, we deploy it on a single region, but it will be on a separate VNet. So, and other management service will be on another VNet. So we will have a VNet peering, but we can recover this service individually, right, without disturbing the other service, because you can recover those services with the same IP. Without any issue. So anytime you can, so with the ASR in Azure, I think you can do your mock test without while running on the production. When you deploy every service in a single VNet, it's going to be very tough. So yeah, I think with those experience, right, we anything which you go on a cloud, have a separate VNet. With a separate IP range, so that it is easy for you or anyone, right, who are designing, will help you to recover quicker. With the RTO, RPO, you can meet it much faster.
Great, thanks, Yuvraj. So okay, so DR networking here, and thank you so much. Just to add that, so he was talking specifically with Azure Site Recovery on public cloud, where they were using the VNet. And so coming back to the DR networking, when we do the DR, whether it's a SRM and or you use Zerto or any other, even if you go for a public cloud, you need to make sure that you have a WAN connectivity, as the production site and DR site will be in 2 different locations, and there won't be any LAN connectivity. So we need the WAN connectivity for 2 things. One is the data transfer, and another is the management. So I've seen customers using the MPLS connectivity for a data transfer, so that it is faster, and it can be in GB. So if you have huge data, like we had a customer called ATOS, and they have some sub-customers, another customer. So they used to rent the MPLS from my company, and we used to rent them huge on that particular part. And on that particular WAN link or MPLS, they used to do the replication on their multiple customers and replicate data to the SunGard data center at Philadelphia. So the feature of MPLS is that enterprise level customers can replicate data in terabytes per day, and making sure they're always replicated to the DR site, and they're always recoverable. And the RPO is low and can be calculated in seconds and milliseconds if they use a storage-based replication with a EMC or a NetApp, and where whatever data is getting changed at production, getting committed same time at the DR site, so that they can have the less RPO and very minimal data loss in the event of disaster. There's another connectivity the small and mid-level customers uses for replicating their data, and some enterprise customers as well, they use IPsec VPN or site-to-site VPN for management as well as replicate data, so that they can have the connectivity with production and DR. I also seen a couple of banking customers, Europe-based customers, they were using MPLS for a replication and IPsec VPN for a management. And whenever they wanted to do the DR test, they used to set up the MPLS connectivity, IPsec connectivity between their particular war room or a separate meeting room, and so that this particular meeting room can connect to the DR environment and do the testing. Because the DR, so when we do the DR test as a vendor, we do the recovery, but there has to be somebody to go and do the validation right? Like infrastructure validation as well as application validation. And as it is test, we can use the application team to go and do the validation and provide the feedback, right? So we can use that feedback and update the recovery procedures and make the changes to the scope, add new servers, remove some servers, and as well as we can update the steps so that whatever feedback we got can be utilized, and we can improve ourselves and make it more easy and decrease the amount of RTO and RPO in future test or actual disaster. So we used to set up the IPsec connectivity from their meeting room to the DR environment, and then they can access the recovered servers without disturbing their production environment and do the DR testing. And there can be a separate replication connectivity, or we can share this replication connectivity between MPLS and IPsec. For that, we need WAN connectivity. When we consider the WAN connectivity, or when we consider the bandwidth, there is some calculation we can use, or there are many calculators available online, which can help you to define or select the throughput for your replication link. Like if you have a very limited data to be replicated, you can go for lower link. But how much Mbps I need to use, you can use a calculation or Excel-based calculators to define your data, daily data transmit from prod to there, or whatever data changes are happening at production. You can easily get that data change rate from your daily production data, and or you can assume 10% of your total data is your data change rate, and you can divide that between the from your production to the DR, and then you can decide that divide that in 24 hours and number of like RPO you wanted to use, or RPO you wanted to have at your between your production and DR, and then you can decide the bandwidth. If you have any network architect in this call, he can easily help you to decide that. We talked about ATOT and ATOD connectivity. So why I mentioned ATOD connectivity, if you think ATOD connectivity, there won't be any connectivity, right? Like production side is not there, but you have your users or your customers. They need to access your environment, right? Like I have a customer called Mattel, and they have their toy business running from their production. And if their Nevada data center goes down, their customers, they won't be able to access Hot Wheels or Barbie website, right? So once we do the DR for them, we need to make sure we go and update their their DNS for web servers are matching with new IP address, right? And once the DNS updated, then only their website will open from the DR side. That's why the ATOT connectivity can be like very easy. Only admin and test users can access via SSL VPN or a site-to-site VPN. But ATOD connectivity needs to be done. You need to think from the users. You need to think from the admins. You need to think from the customer's perspective as well. The same steps which I mentioned here, public and private DNS changes. Like most of the time, when we do the disaster recovery test, the domain controller or the DNS IP which was there in the system for recovered virtual machine is not available. That time you can go and run some script and make sure that new DNS server IP address is there, or you can think about upgrading or changing the DNS IP address, or updating some forwarders in the DNS. So making sure that DNS query gets resolved successfully. You need to have the separate connectivity for admin. Like sometimes users, a company can't afford two different teams, or if they think they have empty office or empty data center was available in some location, Canada, which can be considered as a DR site. So they can think, okay, we can give our admin or DR level access, and they can set up a a DR SSL VPN and DR VDI and DR jump servers to make sure that DR admins or if their production admins can only connect from home and access their DR infrastructure and do the disaster recovery. Or vendor can have, like we used to have customers who were having a AWS disaster recovery destination. So we used to have a dedicated site-to-site VPN connectivity from our data center to AWS AWS infrastructure, or what do we call that? A AWS cloud. I forgot that particular word.
Which one you're looking for?
Right? Like in a VNet, I set up my VNet in Azure. So in AWS, we configured
VPC, right?
VPC, yeah. So
That's
yeah, we used to have the site-to-site VPN connectivity with the recover VPC. So when they declare disaster or having a DR test, our admin or our engineers who do the DR activity will have direct connectivity with their VPC.
Correct.
So this kind of settings were already in place or can be configured or have set up or while doing the DR network connectivity. Thank you for correcting.
No problem.
So yeah, the important part here, prod to DR VLAN mapping. Now with SDN or specifically with NSX and NSXT, we can extend our production VLANs to the DR side. But if you cannot have that extended to any other infrastructure like from on-premise to AWS cloud or on-premise to Azure, that time you might need to change your private IP addresses or the VLAN. So that time you need to make sure that you have a dedicated sheet or a document where you update your prod IP address or a DR IP address and prod to DR mapping, so that when we do the recovery and these DNS updates happens when we do the recovery and your application works. Because without the application, your infrastructure servers will not talk to each other, and without that, your application will not come online. So that's also an important factor to be considered. And failover and failback configuration. Then once you are done with the DR, you also need to make sure that when we do the failback, the similar configuration is reversed and you have similar connectivity configured, because you did the failover because your production site was impacted due to fire, earthquake, or whatever natural or man-made disaster. You need to reconsider and reconfigure all those things while doing the failback. So even you might need to do the reverse application, and everything needs to be replicated from DR to production, and all those things need to be reconsidered while setting up your production site to do the reverse recovery. The next part is infrastructure and application recovery. So when I divided this two in things like why we need to make sure that your application servers will not work unless your infrastructure is up and running, like the Active Directory servers, DNS servers, some always-on servers like Citrix, NetScaler, and other things. Your VDI and Citrix access servers, like SRM servers needs to be always available, or a vCenter server and ESX host. All those things comes under infrastructure recovery. And application recovery, your financial application servers or your database servers or a web servers which are public facing, and some custom application servers. So this list can be very long and depending upon the business and the customer. And then you can have everything documented, and then you can plan this application recovery as per the requirement, like tier 1, tier 2 application, tier 3 application, and then you can think about having the recovery strategy defined for them. But the infrastructure recovery is always tier 0, which means it needs to be always available, or it needs to be recovered first whenever you have a DR. Here, I wanted to talk about test versus actual disaster. So when we do the DR test, it's always schedule and plan activity, but actual disaster is always unplanned, and it's you might get a call from your BCM team saying that, okay, we have a DR and we need to do the recovery, or your DR coordinator might need to might contact you, and you can say, okay, guys, we need to start working on disaster recovery, and then you so actual recovery is unplanned, and you don't have any information. There might be you might need to join a few minutes or few calls, and DR architect or the DR coordinator need to make sure he act step by step and he follow correct order to make sure he do the recovery. DR test is scheduled, right? So you're aware, okay, 5 p.m. we are gonna do the DR test, and you're always prepared. So you will always find a difference in the RTO when we do the disaster recovery and the disaster recovery test. With the disaster recovery test, you can always validate the replication, right? You can make sure, okay, replication is good, we can do the recovery on time. But at the DR site or actual disaster, we need to do the recovery based on available RPO or based on the data you have available with you. DR test can be no impact to production, and your production runs as is. But when we do the DR test, production is unavailable, you need to make sure that you do the recovery as soon as possible to make sure production comes online. DR test, you can use post-test report, and you can improve yourself and make the changes to the DR plan and schedule or DR strategy. And the actual disaster, you need to recover, and you need to recover the servers and application. At the DR test, you need to do the post DR test cleanup, where you can go and delete the virtual machines or shut down the physical servers and revert the changes. But post DR test, you need to work on the reprotect all the servers and bring up the production side back and reprotect servers and fail back. So this is the topic which I wanted to discuss and have interactive, where these are DR life cycle. It's very important, and most of the customer they implement DR, they do the successful DR test, all their DR plans and DR coordination, everything is ready and documented. But slowly over the period of time, they never update their documents, and that's why when they have actual disaster or they go and do the surprise DR test, it fails because the changes to the environment was never documented or never updated at production site. The new implementation never protected or backed up. Whatever upgrade they have performed at production site. Even I've seen some customers upgraded their production infrastructure. Like sometimes they went ahead and upgraded their vCenter server, which was not compatible with SRM, and that was stopping them to replicate their production or keeping the replication or a recoverability was in question while the DR team goes and upgrade the DR site. With this, if we follow the DR life cycle, we can improve the RTO and RPO. Like we can actually identify what is needed and what is not, and we can cut and or improve, or we can add some new servers. We can change the disaster recovery strategy while doing the regular communication with the production team and the ER team. And we can also do the capacity planning for addition and removal of servers, and we can save some billings in there. How to do the DR lifecycle and what are the best practices to have? Like regular meetings with customers. If you're a vendor, you have to have a regular meeting with customers and ask the questions and understand what is changing and what is changed in the last couple of weeks or days. Proactive change notification, like get the vendor added or the be the part of your production team and understand what changes are happening at production, so that you can be ready with those changes at DR site, or you can be ready with the strategy. We can guide production engineers to the DR steps, like what DR strategies, what are the DR strategies, and how do you plan, or how the DR is implemented for XYZ organization, so that DR can, they can use this knowledge to make sure whenever they make any changes, it's adhered to DR. We can do the scope validation and regular meetings where we send the details that this is the scope has been protected or backed up and replicated. And if you want to make any changes, you can make those changes. This also helps to change in the billing so that if customers add new service, that generate new revenue to the customer or to the vendor. So that's also an additional factor. So if you have this regular DR life cycle, you keep on upgrading or increasing revenue for your company. And you can have the scheduled DR test as per quarterly or once in a year or twice a year. That gives you the output of your DR implementation, and you can make the improvement for disaster recovery. And an automated report, you can generate some reports if you have some tools like Azure Site Recovery or Zerto or SRM. So that can send the automated report about the protection and replication, as well as RTO and RPO, which helps customers, vendors, and the DR team to improve the disaster recovery practice. With this all, we are coming to the end of this slide where we can do some question and answers. We have some time in hand. If you wanted to add anything, feel free to add. We can open for question and answers. There was some question. I will just read it. What tools available to stop the replication once we identify the corruption starting at source? A recent ransomware attack. Very good question. So most of the tools, like Azure Site Recovery, they comes also with storage-based replication like SnapMirror or SRDF. We have option to do the restore for a particular time. So it's not like it's tag-based recovery or a time-based recovery. So you have a tags or a time, and it helps you to define what types of data you need to do the recovery. So if you assume, okay, you had a ransomware attack at 8 a.m. today, so you can think about you can think about, okay, before 8 p.m. there was nothing affected or there was no problem, or you can also do some kind of POC to check whether I will just restore a couple of servers which are affected, and we can go back 2 hours or 1 hour back and we can do the recovery. So if you think for going time-based recovery or tag-based recovery in Azure Site Recovery or Zerto, and when we use the storage-based application, you can using the older snapshot for doing the recovery for storage level replication. With SnapMirror, you can it completely depend on your backup architect or a storage architect, how they have implemented or how old data they can preserve with the replication. So this is the only way you can do that.
Thank you, Rahim.
Yeah, you're welcome. Any more question? Okay, if not, I will send this slide. Feel free to go through that multiple times. And if you have any questions, reach out to me. My details is not there in the slide anywhere. I will just quickly update my email ID and name, and you can reach out to me anytime, whenever you need. I will try to help best out of my time, and I will see you in future with some other topic.
Hey, really, thanks a lot, Rahim. Fantastic session. Really appreciate. So I'll also give some slides, for you, so where you can populate this data also. So especially that, the site identification, what are the different parameters you need to look for and all. I got some couple of slides I'll send you so you can populate. But really, fantastic session. I
Sure.
truly appreciate.
Sure,
Great
Nani,
session.
thank you so much. I appreciate it. I will just update this slide with my contact details, and I will send it to everyone. With that, we are just 2 minutes over, and I would really like to thank you so much for joining this session. We'll have a couple of more in future. Thank you so much. Over to you,
Thank
Prasanna.
you.
Yeah,
Thanks.
thanks. Thank you so much. you.